One of the problems that I've noticed with user interface design is that typically by the time the product's delivered, either the user interface is obsolete or it needs to be changed because nobody's bothered to talk to the user. When you're dealing with military software, that problem would seem to crop up an awful lot more, particularly since you're already overloading the notion of the software development with a lot of contract problems. You really have, it's a lot harder, it seems, to change the interface after it's been delivered with a big software product. Programmers tend to get bogged down in the how rather than the why or the what. For example, gee, I have to call this subroutine. I have to get it to behave this way. You spend too much time focusing on what it takes just to get a simple object displayed. You don't think too much about what objects you should be displaying. And an awful lot of the programmers that I've met, myself included, don't have that much of a background in user interface design. You don't have time to look into it. Most programmers are not human factors people. They don't know what works well for the user. And time constraints and schedule constraints preclude going and talking to somebody and saying, hey, look, this is what we have, what do you want, and we'll try to produce it for you.
The need for a standardized way to develop user interfaces for this wide range of systems is paramount, because the user interface systems, the user interface development is becoming a more important part of developing systems. As we have all the hardware we can use, and new hardware is coming out faster than we can use it, actually. The problem is to get this hardware accessible to the people who want to use it. I think the major problem, and from my perspective, is the major problem, is when these new technologies are made available, it's almost an impossibility today to take advantage of them in a reasonable period of time. And what you really would like is to get a general idea of the technology that you're going to use, but delay the decision so you can take advantage of the newest technology that you can.
The approach that the SAI has taken towards solving this problem is a very good one. They've layered things very nicely. You have an application over here. In the center, you have a nice mapping function. And then over here, you have a bunch of technologies. And dropping new technologies in is very easy. And you can drop them in without affecting the application. If we can't use the product, we can use the technology. By technology, I mean the approach to solving that problem. When I first saw Serpent, I thought to myself, wow, I mean, I have a friend who works as a human factors engineer. This would be perfect, because then we can get all our programmer guys off working in a corner on the application, and we can take our human factors guy and put him together with one programmer. And this program doesn't even necessarily need to be, as I said, a crack hacker. You put them together, and they can work on the user interface part of it, develop an interface, somewhat independent of the guys developing the application. And they can test it out on their own, and they can run it against a user. It's wonderful. I mean, it separates a lot of those concerns out. It keeps you from worrying about things that you shouldn't worry about. So if you take a user interface management system such as Serpent, which abstracts away from you a lot of the nonsense necessary to put the objects on the screen, let's say, in the first place, you take away a lot of the effort necessary to produce a prototype. The product like this, by making it easy to do user interface prototyping, has a tendency to make you aware of it at a much earlier phase in the software development life cycle. Wow, look, I can build this little prototype here. This is phenomenal. And I can do it before I've even written any code. And programmers, particularly the really good ones, have a tendency to want to play anyway. So you let some guy loose and he plays for a day and he realizes how easy this is to do, and he becomes more aware that it's an important thing to do.
The most important advantage is that you can use that prototype and easily translate it into the production system. That is, you've spent these resources, time and money on developing a prototype, and you don't have to throw it away. You can actually use it in the production system. And the major advantage is that you can integrate new media into the Serpent system itself. There's no need to reinvent a system to take advantage of a technology. All that's required is that the new technology be registered with the tools that are available in Serpent.
The user interface of a computer system is that part of the system that the end user sees, the part that the end user interacts with. And over the past 20 years, that portion of the system has changed dramatically. 20 years ago, people interacted with computer systems by means of punch cards and got their output back on printed paper. After that, people started interacting with electronic typewriters and, again, getting their output either back on printed paper or through the typewriter. Somewhat after that, there was a movement to glass teletypes, and so people had TV sort of screens that they could interact with. And these days, people interact with computer systems through bitmap graphics, through more sophisticated types of machines. And in 5 or 6 years, there'll be some new type of technology that people use to interact with computer systems. The result of this is that a substantial amount of attention has to be paid to managing the way that an end user interacts with the computer system. Serpent is a general purpose user interface management system. It is based on a particular language that we've developed, which is used for specifying user interfaces. We have under construction an editor which allows for the easy specification of a user interface and for the drawing of the particular displays that are interested, that the user is interested in. We have integrated several different media into the system, and the system currently is primarily based on the Athena widget toolkit based on the X11 Windows system, which is developed by MIT. Serpent is built around the basic software engineering premise of separation of concerns. Those aspects of the system which are specific to user interface are separated from those aspects which are specific to the particular application system being built. In between these two types of objects is a mediator, and we call that the dialog manager. And the dialog manager then takes information that's meaningful to the application and converts it into information that's meaningful to the output technologies, or takes user input and converts it into information which is meaningful to the application-specific objects. The application portion of the system can be written in either Ada or C, and it is written to be media independent. The technology portion allows for the easy integration of new technologies, and the assumption is that a technology consists of a collection of objects which can be manipulated. The mapping portion, the dialog manager, is the runtime system that supports that. The specification of the user interface is done via a dialog. This type of architecture supports the incremental development of user interfaces. In the first stage, a user interface is prototyped through specification in the dialog, and that interface is then tested with users to see whether or not it meets their expectations. At the next stage of the life cycle, an application is written. That application is integrated with the dialog. The dialog is strengthened to be more robust and to cover the cases which were not included in the prototype, and the system is placed in production. The final stage of the life cycle, new technology comes along. That technology is integrated into Serpent. Dialog is modified to incorporate that new technology, and because the application has been written in a media-independent fashion, the modifications by adding new technologies or new media don't affect the application. From a prototyping point of view, again, what's required is the easy specification of the user interface, in particular a drawing capability that allows the end user to see the kinds of displays that they would use, and a simulation capability the ability to exercise the prototype so that the end user can get some feel of what the dynamic behavior is. We'll now see some examples of how Serpent is used in that environment.
This is a demonstration of the visualization component of the Serpent editor. The Serpent editor is one of the initial applications developed both for and using Serpent. What we're going to do here is we're going to create a prototype using Serpent. The first step is to create a background canvas on which to view our design. Once I enable prototyping, the draw menu on the right side of the screen becomes active. There are a number of different command widgets here which I can then visualize. So I'll create an instance of a command widget and then select a position on the form I'd like that command widget to appear. Now there are a number of attributes of this command widget that I can change through direct manipulation. For example, I can change the X and Y location by using the third button on the mouse, or I could use the second button on the mouse to change the width and height of the attribute. Now there are also a number of attributes which can't be changed through direct manipulation. Things like the color, background color, foreground color of the attribute. So what I can do is I can select the widget and bring up a form containing a complete enumeration of all the various different types of attributes. So once I've done this, I can come over here and change, for example, the label text. I'll change the foreground color from black to white, and I'll change the background color from white to black. I'll then apply these changes to the command widget. Now once I've done this, I can still continue to manipulate the object through direct manipulation. So if I select the object and move it down, you'll notice that the X and Y positions change. If I move it back up, they'll change again. And if I resize the object, you'll notice the width and height attributes modifying. I can also come over here and change these attributes through indirect manipulation and apply these changes back to the actual attribute. This whole tool is a means of creating static representations of your design from which slang programs can later be generated.
So, what kinds of things should we look for in a good prototyping tool? First, the ability to construct displays using various interaction objects such as command buttons and scroll bars. In short, the ability to draw pictures so that we can visualize and work with the physical appearance of the system, that is, the static behavior. Serpent provides a graphical editor to allow one to do just that. This graphical editor makes use of whatever interaction objects have been incorporated into Serpent, thus allowing the user interface designer to use the same graphical tools that will be used in the final production system. Next, the ability to model the dynamic behavior of the system. This is an automatic feature with Serpent. If an interaction object has a specific behavior, it is automatically registered with Serpent. Next, the ability to save these items in a form such that they can be recalled, modified, or even included into the final production system. This is one of the real strengths of Serpent, in that the user interface can be modified and represented either graphically or textually using Serpent's internal language, which is sufficiently rich to allow quick prototyping without any application being resident. The application can then be added later on to allow the prototype to evolve into the final production system. Finally, the ability to monitor and record internal communication between different pieces of the system, as well as operator interactions with the system. We can thus see how well the prototype fits in with the end user's model of what the ultimate system must be, and we can also gauge his operator performance. Serpent has hooks in it to allow the recording and playback of both internal transactions and operator interactions.
Serpent is useful not only in a prototyping environment, but also in a production environment. Recall that in a production environment, what's needed is the ability to do abstractions, the ability to have robustness, reasonable performance, and the ability to support arbitrary application functionality.
When we designed and implemented the Serpent system, we were very concerned that it would be useful as a production tool. One way to accomplish that was to provide a mechanism for the user interface designer to specify and easily change user interfaces. To that end, we designed a language for describing user interfaces named slang. The language is a non-procedural language which is data-driven and based on the production system model. Whenever a piece of data changes, any other dependent data automatically changes. The user need not explicitly specify these dependencies. The system can determine them from the description of the user interface in slang and automatically maintain the consistency between all the pieces of data within the slang program.
In the Serpent dialogue model, there are, at the lowest level, there's these things called interaction objects. Interaction objects correspond to objects defined in the presentation technology. For example, if you're using X Windows, examples of interaction objects would be command widgets, windows, dialog boxes, this sort of thing. Interaction objects have attributes which help define the presentation characteristics of the objects, and methods which can be used to specify what sort of actions to take on user-generated events. Well, once you have these interaction objects, basically all you have at this point are static displays, and you would now like to control the display and removal of these objects from the display. In order to do this, we have a mechanism called view controllers. The dialogue model on a whole is based on a production model, which basically means that things are A, data-driven, and B, constraint-based. So an example of what this means is that you can define constraints between various components of the system, and those constraints will be automatically enforced by the system.
Within the slang program, the constraint mechanism uses one-way constraints. During runtime, these constraints are evaluated via an eager implementation technique, which means that the dependent data is automatically recalculated whenever the independent data changes, as opposed to only being recalculated when the dependent data is needed.
It's important when you're dealing with user interfaces, whether from a prototyping perspective or a production perspective, that the system be powerful enough to create highly interactive interfaces and that the system be powerful enough to support limited types of arithmetic. In the next demo, we'll see the use of Serpent to build a visual programmer which enables one to construct an arbitrary arithmetic expression. We have, in this demonstration, the ability to choose various operators. We'll start by choosing a plus. We'll then position this plus on the screen. We now need several arguments, which will provide the numbers which are going to be added. We need to connect the lines that show that the output of the arguments goes as input into the plus operator. We have the ability to move around, and the lines will follow the particular operator until we find the right place. We now input several numbers and calculate an answer. Now we want to multiply this answer by another number. So we choose a multiply operator. Now we connect its lines. I have to generate another argument here so that I have a third number to put in. It's got to be connected. Now I put a value in here and say I want to do the calculations. So the calculations are done. If I want to see intermediate values, I can examine intermediate values. Serpent's useful not only in prototyping and production, but also once the system has been fielded. The requirement to support post-deployment is that new technologies can be integrated into the system in an evolutionary fashion.
Large systems may take as long as 3 years to develop. During that time, displays and other input-output technologies will have made great leaps forward in both functionality and performance. New toolkits will have emerged, such as those that are offshoots from the X-Window system. It would be nice if we could take advantage of these new technologies, new toolkits, faster displays, as they emerge during the post-deployment phase, sometimes called operations and maintenance. Unfortunately, in many cases, applications are written such that they are dependent on the technologies being used within the user interface. At the very least, the applications make assumptions about the way the data is going to be displayed in the final system. Through the separation of application functionality and user interface concerns, Serpent enforces that application code be independent of the user interface. Thus, when a new technology or toolkit becomes available, it can be readily injected into Serpent, replacing existing user interface portion without affecting the application. This is also handy during prototyping, as one can experiment with different user interface styles, again, without impacting the application.
We've seen the use of Serpent in prototyping, in production, and in post-deployment. Serpent, as it currently exists, has some limitations which will restrict its usefulness for arbitrary applications. But it provides a proof of concept that a single tool can, in fact, handle all these three aspects of the life cycle. And it provides the promise that either improvements to Serpent or follow-on systems along the lines of Serpent will dramatically reduce the cost of the life cycle associated with the user interface.
This separation of concerns is a very strong, good, solid software engineering model. And we need to be pushing this. And at the very simplest level, just taking Serpent and saying, look, it can be done. Not only can it be done well, and it can work.